Welcome back. This is Signals and Systems Tutorial 5A. In question 1, we are asked, why is the Z-transform a sequence? Why does it become a surface in the Z-plane? Let's recap on the equation. This is the sequence, the input sequence, and it can go from negative infinity to infinity. And the Z-transform asks us to multiply each coefficients of the sequence by z to the power of minus n, where z is the complex number. We can then choose any complex number, put it in here, and then we'll calculate this series. If this series converges, then we have x of z at that particular z. If this series does not converge, then x of z is not defined at that point. Now, what is z? Z, remember, is the entire complex plane. So if this is the 0, the origin, this is 1 and this is 2, this is minus 1 and minus 2, this is j and 2j, and so on. So therefore, when we calculate using different z, we would get also a complex number. So we are plotting x of z. Now, x of z, because it is a complex number, will have a real and imaginary part. Typically, we'll plot the real part, sorry, not the real part, the absolute part. We call it the magnitude, either the absolute value or the log magnitude. So, we'll plot the absolute value against the z-plane or the log magnitude against the z-plane, and hence what we have done is to convert a sequence into a surface in the z-plane. So this is what we have just said. It is a mapping from a function in n to a function in z. And you will need to consider which set of z will make the series converge. This set of z has a special name, which is called the region of convergence. Why do we do all this? It is that certain operation in the z domain is much easier to be performed, such as convolution, and hence when we convert a sequence into a surface, the surface of x of z allow us to perform some operations which is easier. So this is the motivation of xn to xz, as well as why xz is a surface. Thank you.